Right, just going to be looking at integration by substitution question. It's a past paper question from the Edexcel. So to start with, we've got this figure 2 here, which shows the curve with equation y equals 3 minus x plus 1, all square rooted. And we want to use the substitution x equals 1 plus 2 sine theta to show that this is equal to this. So the first thing you should always do with your substitution is you should differentiate it. So let's get our substitution. And you get a mark straight away if you differentiate this. So let's differentiate this with respect to theta. And 1 goes to 0, and 2 sine theta will go to 2 cos theta. And we've got our limits of 0 and 3. So when x is equal to 0, then we have sine theta will equal pi minus pi by 6. The way we do this, we've got x is 0, take away 1 gives us minus 1, divide by 2 is minus a half. And if you think about your sine curve, okay, minus a half is about here. Going back, that's going to be at minus pi by 6 radians. And x equals 3. Then we take away 1, we get 2. Divide by 2 gives us 1. So we can see that sine theta will equal pi by 2. If you do inverse sine of 1, you get pi by 2. Now let's put all the substitution in. So that means that the integral from 3 to 0 of the square root of 3 minus x open brackets x plus 1 dx will equal, let's put the substitution in. We've got the limits pi by 2 and minus pi by 6, and they're given to us anyway, so it's quite easy to just do that. And then we've got the square root of 2 minus 2 sine theta open brackets 2 plus 2 sine theta. And then we're going to put the substitution in. Now dx will equal 2 cos theta d theta if you times by the 2 theta. So we replace the dx with 2 cos theta d theta. And what we're going to do is we're going to simplify this. So we get 1 minus sine. If you take the 2 out as a factor and take the 2 out as a factor, so we've got 4 out as a factor, we can take that outside the square root as a 2. So let's just take the 2 out. And that's leaving me 1 minus sine theta times 1 plus sine theta, where if you know your difference of 2 squares, you're going to get 1 minus sine squared theta when you multiply that all out. And I'm going to show you all of that now. You can do that yourselves. If you're doing integration by substitution, you certainly can work out that multiplication for yourself. 1 minus sine squared is cos squared. Square root of cos squared is cos. So we've got 2 cos theta times cos theta. Cos theta will be here. So we're going to get another 2 coming out, which leaves us 4 times the integral from pi by 6 to pi by 2 of cos squared theta d theta. So my k is equal to 4. Moving on, I'm going to do this integration over here. So we've got 4 times the integral of minus pi by 6 to pi by 2 cos squared theta d theta. And that is just going to be equal to, well, if we use our double angle formulae, cos squared theta is equal to a half of 1 plus cos 2 theta. And what you can do, if you want to just confirm that, you can look up cos 2 theta is equal to cos squared minus sine squared, which is 2 cos squared theta minus 1. Rearrange that to get cos squared on its own, and you realise that cos squared equals a half of 1 plus cos 2 theta. And then we can just integrate that nice and easily. So we get the half. So if we've got half times 1 times 4, that will just give me 2. If I integrate that, I'll just get 2 theta. And then I've got a half times 4, that's 2 cos 2 theta, which must come from plus sine 2 theta, because the 2 will come out when you differentiate this. And we're going to put our limits in. So put pi by 2 into this, we get pi. Put pi 2 into this, we get 0. Put minus pi by 6 into this, we're going to get a minus pi by 3 when you double that. And then put minus pi by 6 into sine 2 theta, we get minus root 3 over 2. So if we do this, minus pi by 3, we get 4 pi by 3. 0 minus root 3 over 2 will give me a plus root 3 over 2. And there's our final answer.